Alright, welcome everyone. In this video we're going to do a 14.1 problem. We're in an exam from 2016, looks like fall semester here. We have a nice function and we're interested in domains and ranges and level curves and all that good stuff. Alright, so let's start off with the domain. Remember, this comes back from our good old algebra days. We don't like, to divide by zero. Square roots shouldn't have any negatives inside of them. Natural logs don't like zero or negatives, right? So those are kind of the basic rules here. So I noticed that, right, there's no division, there's no natural logs, but there is a square root. So the thing that I plug into that square root, in this case 25x minus y squared, we want to make sure that that's greater than or equal to 0. All right, so at this point we can go ahead and rearrange. And I'm going to make this 25x should be greater than or equal to y squared. And I can divide by this nice positive 25 here. So this is going to be y squared over 25. And this is what I would like to sketch. Now again, usually the way that I sketch these inequalities is that I first think about the corresponding equality or equation here. So I'm going to go ahead and sketch x is equal to y squared over 25. And maybe we're getting pretty good at, these nice quadratic curves and you're happy you know exactly which way this parabola opens. But if you're at all hesitant, the claim is you should choose some test points. So for instance, I think it's easier in this case to choose y values as test points, right? So if I chose the y equals 0 in this case, well, 0 squared divided by 25, that's going to give me x equals 0. So this tells me that it goes through the origin. Y equals 0, x equals 0. Now another nice point to plug in is maybe be like y equals 5. Right? Because if I plug in y equals 5, let me actually write this down, y equals 5, I would get 25 divided by 25, so that gives me x is equal to 1. So maybe I would plot the point x equals 1, y equals 1, 2, 3, 4, 5, so something like this. 1, 2, 3, 4, 5, one more. There we go. And also if you chose something like y is equal to negative 5, right? I notice that I'm squaring this, so it's still going to be 25. I divide it by 25, and so I'm going to get the same result, right? X is equal to 1. So even if y is equal to negative 5, 1, 2, 3, 4, 5, I still get x is equal to 1. And so we're going to have a parabola, and now we clearly see that this is opening in the positive x direction, right? It's opening to the right, so it looks something like this. And there is our parabola, and now we have to know where to shade, right? So I think x should be greater than this parabola. Well, here are where all the big x values are, right? So I'm going to go ahead and guess that I'm shading over here. But again, if you're ever at all hesitant about which side should you shade, or maybe you should shade both sides, right? You should choose some test points. So if I go ahead and I choose the test point, for instance, this one's a fine one here. If I chose 2, 0, so 2 for x, 0 for y, and I plug that back into my original inequality. So let's see, this would be x is 2. Is that greater than or equal to y squared over 25? Well, yes, 2 is greater than 0, so yes, this works out, so I should shade that area. However, if I was to check another test point, maybe on the other side of this curve, maybe something like negative 1 comma 0, and I plug that into my inequality, right, that would give me that negative 1 should be greater than or equal to 0 squared over 25, and that's certainly not true, so I should not shade that region. So okay, there we go. That's how we can decide which side to sketch or to shade in. The last thing, right, is that we need to go back and we need to decide, looking at this line right here, should this be a solid line or should it be a dashed line, right? Well, in this case, we have x is greater than or equals to, right? So therefore, equals to is fine. Therefore, we want to include the x equals y squared over 25. So I'm going to include this as a nice solid line. If this was just strictly greater than, then I wouldn't want to include it, and it would be a dashed line. All right, so there is part A. Let's go ahead and move on and think a little bit about part B, right? What is the range of f of x, y, right? Okay, the range, we have to think about what kind of values can this spit out. And so when I want to start with this, I'm thinking about, right, this square root, right? I know square roots only spit out positive values. So already I'm thinking, right, 0 to infinity, right? Square roots can spit out 0, they can spit out positive values, but now I see that this, I'm adding 1 to it. So if the square root's spitting out 0 to infinity, and then I go ahead and I add 1 to it, well, that means that maybe I'm spitting out something like 1 to infinity, right? Because I'm adding 1 to all of those positive values. So 1 to infinity is what I'm thinking about for the outside function, right? And then we have to look at the inside function and think, is there any reason why I wouldn't be able to plug in very large numbers, right, all the way from 0 to infinity? And I'm thinking, okay, well, no, there's no real reason, right, because I could just let y be equal to 0, and x could be, whatever quantity I would like, right, and this will get all of the very positive numbers all the way down to 0, so there's really no restriction about the inside. So therefore, the range, again, there's not really... it's more kind of guess and check, going back and forth. It's a thought experiment to try to figure out the range. So the range is from 1 to infinity in this case. All right, finally, part C, we would like to sketch the level curve of f of x is equal to, f of xy is equal to 4 on the plane below. So let's go ahead and set up my f function. That's 1. Oops, not let me write there. There we go. 1 plus the square root of 25x minus y squared is equal to 4. And now we want to sketch this, right? So let's go ahead and rearrange this. I don't know how to sketch this one, so let's try to rearrange a little bit. Let's make this 25x minus y squared is equal to 3. Let's go ahead and square both sides. So I get 25x minus y squared is equal to 9. And let's go ahead and rearrange kind of like we did before here. I'm going to make this 25x is equal to y squared plus 9. And then I'm going to divide by 25. So x is equal to y squared over 25 plus 9 over 25. Okay, so maybe you're really happy about sketching this, especially after we already sketched, right, x is equal to y squared over 25, right? So now all we're doing is we're adding 9/25 to x. So that's just basically going to shift this parabola over a little bit, right? We're going to have something like this where it's shifted over 9/25 or so. So something like this. But again, if you're ever at all hesitant about what does this curve look like, right, you choose test points. So right, if I was to choose maybe y equals 0 as a test point, right, so I choose y equals 0. When I plug that in, I get x is equal to 9/25. So at y equals 0, we have x is equal to 9/25. So maybe there's that point there. If I chose something like y is equal to 5, similar to as before, right? Y is equal to 5, I would get x is equal to, let's see, 5 squared is 25. 25 divided by 25 is going to be 1 plus 9/25. So, okay, when y is 5, 1, 2, 3, 4, 5, this x value right here is 1 plus 9/25. So it's just this point right here, 9/25, but it's shifted over 1. And likewise, when y is equal to -5, I go ahead and I plug that in. And again, -5 squared is 25. 25 divided by 25 is still 1. And so I get 1 plus 9/25. So when y is equal to -5, we get that x is again, this value right here is 1 plus 9/25. Not the best parabola in the world, but okay. There we go. All right, so there is the level curve. Again, you should always make sure, go back to your domain, right? Your level curve should be inside of your domain. Right, so yes, it looks like this is inside of the domain. If it's not inside of the domain, be very concerned, right? If you were to accidentally sketch something like this, for instance, right, we can tell that that would be wrong because it's not in the domain, right? It's outside of the domain, so this is certainly not where f of xy is equal to 4. In that case, right, if it's outside here, f of xy isn't equal to anything, right? It doesn't make sense to plug it in. We get a non-real answer. All right, and that's all there is to it. That's this problem. I hope you guys enjoyed, and I'll see you next time.